Alright, so this video is going to be it's like a cheat sheet on all different types of confidence intervals since we've gone through a lot of different types of confidence intervals, so it's important that you know how to go between all the different types. So um, first we're just going to talk about confidence intervals in general and then go through each specific one and the formula and conditions that go with it. So anytime you're dealing with a confidence interval formula, like on a free response question, the first thing you want to do is state what type of confidence interval you're dealing with, so the name of the confidence interval. Then also with that, you want to check your conditions. Then you want to calculate your interval. And then lastly, step 3 is you want to interpret your interval. And remember the way that we do that, we say we are blank percent confident that the true mean or true proportion or true regression slope, whatever type of interval we're dealing with. Then you want to include context. So insert the context of the question right there is between blank and blank. This is going to be the low and high edge of your confidence interval. Now going on to the general formula for a confidence interval. So remember, our confidence interval is our point estimate plus or minus our margin of error, which is our critical score. So that could be a critical z-score or critical t-score, depending on what type of interval we're dealing with, and then times our standard error, or another way to think about it is like our standard deviation. All right, so use this as a framework, and I'm going to be referring to each one in reference to this. It's going to help you memorize these different formulas. All right. So the first confidence interval we learned this year was a one sample proportion confidence interval. So the conditions for that, you just want to make sure it's a random independent sample. And then you got to do the n times p. I forgot to put the hat on that, so I'm going to do that right now. So you take your sample size times the proportion from your sample. You multiply those together. They have to be greater than or equal to 10. And then you do sample size times 1 minus the proportion from the sample, and that needs to be greater than or equal to 10 as well. So those are the two conditions. The 10% rule, the AP test isn't really looking for that, so you don't have to worry about that. So for all these, usually there's just going to be two conditions. I'll make it a little bit easier for you. It's random independent sample, and then your large counts rule, which couldn't change for each type of confidence interval. So then for our formula, for our point estimate, we take our sample proportion. Anytime we're dealing with a proportion, we're going to be using a z-score. So you take your critical z-score. The way we get that is inverse norm in your calculator, and you take the area of the tail. So if we had a 95% confidence interval, the area that we put in is 0.025. If we had a 90% confidence interval, the area that we put in for our tail is 0.05. And then we have our standard deviation formula, which you do not need to memorize this. This is going to be on the formula sheet, which there's another video right before this, which I walked you through it. So you don't have to have this memorized. You might already have it. If you do, that's fine. But if you don't, go back and check that formula sheet on your AP test, and then you can write that in. But you need to know the rest of this is not on the formula sheet. So you just don't need to memorize everything except the standard deviation. The standard deviation will be on the formula sheet. Everything else will not be. Then we have a one sample mean confidence interval. So that's more than a confidence interval with just one sample that we're dealing with. So again, random independent sample is one of the conditions. And then since it's a mean, our sample size needs to be greater than or equal to 30. Or if our sample size wasn't greater than 30, we wanted to graph our data as a dot plot and want to say it's approximately normal. And then our formula is we take our sample mean plus or minus our critical t-score, which is going to be inverse t in your calculator. And then we multiply it by the standard deviation of your sample. Okay, And again, this one's also going to be on the formula sheet, so you don't have to memorize it if you don't want to. Then we have our two sample proportion confidence interval. So the conditions stay the same. You want a random independent sample. And then the large counts one's the same as before, except since we're dealing with two samples, you just have to do it with both samples. So easy way to memorize that one. It's the same as the one sample, you just got to do it twice for both of the samples. And then for our point estimate, we do the proportion from sample 1, then minus the proportion from sample 2. Critical z-score, remember inverse norm. And then we have our formula over here for the two sample proportion. Again, that's going to be given to you on the test, on the formula sheet. Next, we have two sample mean confidence interval. So a two sample mean confidence interval, just have that same condition, needs to be a random independent sample. And then both our sample sizes need to be greater than 30, or when we graph them out, they should be looking approximately normally distributed if they're less than 30 when we graph them as a dot plot. Our formula, we take our point estimate is going to be sample 1, mean of sample 1 minus mean of sample 2 plus or minus the critical t-score, and then we plug in our standard deviation formula right there, which is again straight out of the formula sheet. Then the last one, which we learned in chapter 12, which is our regression slope confidence interval. So the main conditions you need to know, you want to make sure that the data falls within a linear pattern. So you want to look at the scatter plot to see if it forms a linear pattern, or look at the residual plot to see if there's that randomness, which means that it's a linear model. And then also, just like before, we want to make sure our data comes from independent random samples, or if it was an experiment, independent randomly assigned treatments. Then our formula, this one's actually probably the easiest one, because we take our sample slope, which we get from our computer output table. You can go back and look at the Unit 3 cheat sheet to look and get a review where they find the slope on the computer output table. That's something you really need to know how to do. We take our critical t-score and then multiply it by our standard error for the slope, which is also going to be in that computer output table. So for this one, you don't have a crazy formula you have to put in. You just need to know where to get that standard error from the computer output table and plug it in to that part of the formula. So that's basically going through all those different confidence intervals. When you're studying this during those first 15 minutes of your study sessions, this would be a great sheet to go through and making sure that you know the differences between all these different confidence intervals, all 5 different ones that could come up on the test. And that's going to help you as you do the practice tests when they come up, be able to differentiate which one's which quickly as you're going through the practice problems.